Assalamu alaikum everyone. Today we have to start this chapter number 7, which is about the estimation of the capital cost. And in this chapter we will mainly talk about that how we can use the previous or the literature data to find out the cost of the equipment in the today's value, and we will see different types of equations and different types of methodologies that we can actually use to get some accurate cost analysis. And we have seen there are different ways to estimate the profit margins of a process and to analyze the feasibility of the process. So it depends how much effort you put on on the design of the equipments and what accurate data you have got from the analysis that can be used for the cost estimation. So we will see different tools in this chapter to estimate the capital cost and how we can actually get this cost data from the already installed plants, and what are the different equations that we can use. Okay, so let us start with this chapter. The definition: the cost associated with the construction of a new plant or modification of an existing plant. So the capital cost, it is about the construction of the new plant, what should be the cost of the new plant, or if we are doing some retrofitting to the existing plant or we are doing some modification in the existing plant, then what could be the new cost of the equipments that we are going to install into the existing plants. Now there are different types of cost estimates and at different levels. Okay, so the types of capital cost estimate: order of magnitude estimate. So this is the first type of this one cost estimation, which is the most basic one. Now here you can see that it is given the information on the magnitude of the cost and the equipment. So we will see that how the magnitude of the equipment, say, it can reflect the cost. So we will see all of these one by one. So the second category here: study, estimate the major equipment. So here you have to consider the equipment types and the size of the equipment. The preliminary design estimate: now here you have to put more efforts in the design and you would get more detailed analysis in terms of cost. Number 4, definitive project control costs. So we will see this one: what are the parameters and what kind of level of design is required to estimate the cost in this domain. And the final one is the detailed firm or contractor's estimate. So this one is the most detailed cost analysis that we get from the contractors, and it contains all the information from the process point of view and from the piping and the instrumentation point of view. So we will see all of these one by one. Now the first one, order of magnitude estimate, and what are the factors that we need to consider in this type of cost estimate. And now in this one, what is the data that is required here? Cost information for the complete process. Now for here, you should have the cost of the complete process. So you should get this cost from the block flow diagram. Now what kind of cost you can consider here? So maybe you can take the cost from the previously built plants, and then you can use some kind of scaling factors or the magnitude factors that can reflect what is the size of the old plant, what is the size of the new plant, and then we use some simple equations to get the idea about the new plant. The second category is study estimate of the major equipments. Now in this particular domain, what data you need here: list of the major equipments and the PFD. So once you have the PFD, you know what are the different equipments that you have in the process. It could be pumps, compressors, turbines, vessels, heat exchangers, distillation column. So you can have some main idea about the equipments that you're gonna have in the process, and you can have some rough estimate about the size of those equipment, length, diameter, or in terms of heat exchanger, what could be the expected area of the heat exchanger. So this preliminary information would be required to do the estimate on the major equipments and what could be the initial cost of these equipments. Now the third category, as we are moving down, we are getting moving towards the most moving toward more advanced stages of this cost analysis, and more detail would be included. Now the third category here, preliminary design and the scope. Now in this particular domain, what we're gonna have data, we should have some data about the accurate equipment sizes, here we need some rough equipment sizes, but now here we should have more exact values of the equipment sizes. For example, in case of distillation column, the length, the diameter of the distillation column, the number of stages, the pumps associated with that one. So more details would be required in this particular type of cost estimation. Layout of the equipment, horizontal equipments, vertical equipments, what kind of piping would be there. Okay, instrumentation, what kind of different instruments we can install on the plant or on the specific equipment, and what is the electrical requirements and the layers. Okay, so we need to have some more detailed information on the equipment and the associated equipments that we need to have with the main equipment. Okay, and now for this particular estimation of the cost, you should have the PFT and preliminary P&ID. So you should have these two diagrams to get some insights about the detailed equipment sizes and the associated equipment. Now the fourth category, which is about the definitive project control estimate. Now for this one, what information you need? The detailed specification of all the equipment. Now here, the specifications of each of the equipment, you should have which equipment you're gonna use, the dimensions of those equipments, and sometimes like you need to have like vessel sketches, the plot plans, and the elevation diagrams. Okay, along with the specification of the equipments. Similarly, you should have an information on the utilities, what kind of utilities you can have in the process, the flow rates information, and all that. Similarly, instrumentation design should be more in detail, what kind of different instruments and what are the different types of instruments we can have, and electrical and the offsite cost. Okay, so you should have this kind of information in the more detailed one to estimate the value for the plant. This is called as definitive project control estimate. For this cost, you should have an information on the final PFT and the preliminary P&ID. Okay, now let's see the last one, which is the detailed firm or contractor's estimate. Now you can see from this name that this is the final stage of developing or making any cost analysis. So that is why we are involving the contractor information and what should be the actual purchase of the equipment. So the data that you require here, complete engineering of the processes and all related offsite and offsite on-site costs and the utilities and the vendor quotations. So now here you can see that we should have the final PFT and the final P&ID, and you should get some quotations from the vendors to see what is the final installation cost of the equipment, what should be the specification of those equipment. So all the details would be the part of this final detailed firm or contractor's estimate. Okay, now we will see that how these different types of cost it can give you the accuracy of the result. Okay, now this table, what you can see here, there are 5 classes here, so relevant to each of these types here that we just studied, there is a class. Okay, so maybe the last class, the class number 1, it is representing you the final stage, the detailed firm or the contractor estimate. Okay, so it will include all the the very good cost analysis of all the equipments and the good comparison with the already existing plants. Okay, and if you are moving upward, class 5, it is the lowest class uh, you can consider. Okay, so the level of information is very less, and maybe you're just simply relying on the BFT. Okay, so maybe the order of magnitude estimate would be there in the class 5. Okay, so the accuracy of the cost that you would do in the class 5, it will be very low, and in the class 1 you are having much information on the process. So you see that there is the level of the project definition. So you define each and every like piece of the project and the equipment details. So that makes a class 1. And if you go in the class 5, you would see that there will be very less information on the project and very less information on the equipment sizing and everything. Okay, so if you are moving from class 5 to 1, we see that there will be a level of definition would be increasing, and in the class 1 you would be having like more detailed information about the process in terms of equipment, sizing, piping, and instrumentation. Now let us see this one, the expected accuracy range and the preparation effort. And now here what you would see here, if you are having the very detailed analysis about the process in terms of design of equipment, sizes, valves, fittings, piping, instrumentation, layout, elevation. So the results that you would get from this one, the class 1 analysis, it would be like the very good, and there will be very less variation in the results. Okay, so it will just vary in the range of plus minus 1. Okay, but as you are moving upward, you are moving to class 5, you would see that the results or the equipment cost that you would calculate, it can vary uh, from 4 to 20 times of what we calculated in the class 1. Okay, so more efforts you are putting, the better cost analysis about the equipment you would get. Okay, now here preparation effort. Now this preparation effort, it reflects you that how much is the cost that you need to spend on doing the cost analysis itself. Okay, so nobody is like giving you the cost estimate free of charge. Okay, so there are some companies that can develop the feasibility, and they give you the details about the cost of the process. Okay, so this represents that you spend more money in doing more analysis, so the better cost estimate for making a new plant you would get. Okay, so in the class 5 what we can see here, so you would just spend a small amount of cost. Okay, but this cost, it will give you very less accuracy, and maybe the actual cost it would vary. But if you are moving downward towards a class 1, so you would probably spending like 10 to 100 times more cost on doing the cost analysis, and you are hiring some good companies which can develop the good feasibility. So maybe you can spend more amount of money on doing the cost analysis that would reflect the accurate cost that you have to spend on the actual project. Okay, so these two things, they just move side by side. You spend more money on doing the cost analysis, the good cost you would get from the vendor or from your company. Okay? So we will solve some of the examples to see the impact of these two things on the process. Now, class 1 plant cost estimation accuracy plus 6% to minus 4%. Okay. Now, here what you would see, if we are using the class 1 analysis here, now what would happen? Plant cost estimation accuracy. So the accuracy of the plant would vary from plus 6% to minus 4%. Class 5 study cost estimation accuracy, it is 0.015 to 0.30 of the total plant cost. Okay, so in the class 5 study, so what we can see here, that if you spend a less amount of money on developing the cost analysis, the more fluctuations you would be getting at the actual plant cost estimation. So for example, in the class 5, you just spend like 0.015 to 0.3% of the total plant cost. So what would actually happen? You would be spending very less amount of money at this stage, but what can actually happen, it can give you the inaccurate result, and maybe the actual cost of the plant would vary from 4 to 20 times. On the other hand, if you are like if you are doing the class 1 analysis, then the actual plant cost would just vary between plus 6 to minus 4%. So there is a trade-off that we can see from this chart. You spend more money on doing the cost analysis, the better or the accurate results you would be getting at the actual build-up of the plant. But if you spend less amount of money on doing the cost analysis, maybe the actual erection cost or the cost that you required for the purchase of the equipment, they may vary from 4 to 20%. Okay, so it is better that you spend more time and more money on doing the better cost analysis that would actually reflect the amount that is required by the construction of your plant. Okay, now let us solve this example 7.1, and the estimated capital cost from a chemical plant using the study estimate method class 4 was calculated to be $2 million. If the plant were to be built, over what range would you expect the actual capital investment to vary? Now we are developing the class 4 analysis here, and you would see that what should be the level of accuracy. It can vary between 3 to 12% of the actual cost, right? And now we will see that what would be the effect of this class 4 analysis on the actual result. Okay, now we would calculate the two costs here. First one depending on the lower value and the other one depending on the higher value. Okay, now 3 to 12%, you can see this one, the minimum range is 3 times and the maximum it could be 12 times. Okay, now here we can see that this one, the $2 million, it is the cost of the plant, and then we have to compare this one with class 1. What we have in the class 1, we have seen that it can vary between 6 to minus 4%. So we would do the analysis with the 6% here for the high value, and for the low value we would do it with the minus 4%. Okay, so 1 plus 0.06 and multiply by 3 to estimate the like what is the expected accuracy range compared to the class 1. So it is 3 times. Okay, so the 3 times we can do this one here, multiply by 3. So the new value that we get for the high value of the actual plant cost, it will be $2.36 million, and the low value for actual plant cost, it would be 1.76 million euros. Okay, now here you can see it's the same way we have to estimate the high expected cost range. Now the actual plant cost is here, then the positive side of this one, the plant cost, that is plus 6%. 6% multiplied by 12, that is the number of times in the class 4. So the cost that would be here, it will be $3.44 million. Low value for the actual plant cost. Now the same way, actual cost 1 minus 0.04, and because we have to compare this one with the class 1 also at the same time, so minus 4 here, multiply by 12 times, that could be the variation in that in the class 4 analysis. Okay, so you would get the cost between 1.04 million euros. Okay, now here what we have done overall, we have taken the actual cost of the plant, then we take the variation that can happen in the class 5 sorry, in the class 4, it can vary from 3 to 12. So we have to consider both of these, and then we have to make the comparison with the class 1 analysis. Okay, so how much variation can be actually we can have in the class 1, it can vary between 6 to 4%. So we have to consider all of these factors to get the value for the low expected cost and the high expected cost, and these are the costs that we have calculated. Now example 7.2, compare the cost of performing an order of magnitude estimate and a detailed estimate rate for a plant that costs $5 million to build. For an order of magnitude estimate, the cost of estimate is in the range of 0.015 to 0.3% of the final cost of the plant. Okay. Now for the higher value, higher expected value, you can have the cost of this plant here. So you can multiply with this one for the higher value 0.003. Okay, 3.3%, and for the lower value you can have this one, the actual cost with this lower percentage 0.00015. Okay, so that is the cost that is required for doing the cost analysis. Okay, now for the detailed estimate, the cost of estimate is in the range of 10 to 100 times that of the order of magnitude estimate. Okay, now we have to consider this one, the order of magnitude estimate, which is the last class here. 10 to 100 times we have to spend more cost on doing the cost analysis. So we can see here, okay, actual plant cost, it is $5 million. Okay, so what we can do here, the higher expected cost, we can have 3%. Okay, instead of this one we can multiply this one with the 10 here, so it will become 3%. Okay, and then we in terms of percentage, it can be equal to 0.003. Okay, 0.03. So that would give you the result $150,000. And lower expected cost, you can multiply this one with the 10, so that would be equal to 0.15%, and in terms of calculation, it will be equal to 0.0015. That will give you the value $7,500. Okay, so for this one, the highest cost, what we can see here again, so you have to multiply this one with the 100. and divide it by the 100 again in terms of percentage, so it will be equal to zero point 0.3, the same value that we get here. So the higher expected value, it will be $1.5 million. Okay, and the lower expected value, we have to go multiply this one with the 100 to have some percentage, and then in terms of calculation we have to again divide it with the 100. So ultimately it will be equal to 0.015. So the minimum or the lowest expected cost, it would be 75,000. Okay, now we have seen that here, if we are using simply the order of magnitude, the for this class order of magnitude, then there will be very less amount of cost, the higher and the lower, okay, both of them. But if we are doing the detailed analysis, the cost can vary between 10 to 100 times. So you can see this one, the 10 times cost, we can see an increment here, and the 100 times cost increment we can see here. Okay, but if you spend like more amount of money on doing the good cost analysis, then that cost would be actually required for building your plant.